COO of MCWL Paladin Geological Services, and this is my introduction to mudlogging. So yeah, it's kind of an outline. We'll go over some fundamentals, mudlogging, rig site understanding. Obviously, the big thing in the oil field is always safety, so that's big on everybody's mind. Key components of like mudlogging equipment, gas detection, stuff like that. Processes and techniques that we use for mudlogging. Then the overall interpretation of the data, going in and building a mudlog. Applications and the significance of what it can bring and offer for an E&P company in the oil and gas industry. And we'll also go over some of the advanced scientific stuff that we can do at MCWL specifically. Fundamentals of mudlogging, we're the eyes and ears of geology on location. They depend on us for a lot of things. A lot of times, they first ask questions, last to know. We offer real-time monitoring of all parameters, drilling fluids, everything on location. The Mudlog is a one-stop shop for any information that you might ever need on a drilling location. Continuous real-time monitoring, drilling fluids, cuttings, just like I was saying, subsurface formation analysis, tops, hydrocarbon analysis, analyzing the cuttings, gathering all the critical data on the subsurface geological formations, and building that mudlog to provide all the information in one spot. Helps support for the decision-making processes, geosteering, going up, down, left, right. And then that all goes into safety as well, whereas we're monitoring pressures, fluid levels, all the rig sensors we're paying attention to all the time because it affects our gas readings also. Excuse me. Biggest role of mudlogger is sample collection. Can't overstate that enough. If you don't get good samples, then what's the point of being out there? That's where the data comes from. For the geologist, that's our client. That's the biggest thing we need to know. Along with that, gathering the data from the drilling fluids, mud weights, viscosities, low grav solids, all that goes into account for our gas systems and detection of the gas readings. Also helps identifying the hazards. If we see a drop in mud weight over, with a high gas spike, we're getting gas cut in drilling fluids, and that's going to cause an instability in the wellbore. Hydrostatic pressure of the wellbore is going to drop in that case. Providing continuous feedback. We're constant sounding board for the geologists, going, back and forth with what the samples look like, what this show does, what that connection gas was from. Mudloggers providing real-time feedback to optimize the drilling efficiency. We're able to give real-time data to the company man, drilling engineers, geologists, directional drillers, all right there with showing what the samples look like of this formation at this depth, so they can target, better ROP, faster ROP, better efficiency. That's the name of the game now. Everybody wants to go fast. Above all else, communication. If you can't talk to somebody, then you're not getting anything. They're not getting anything from you. You're not learning anything. They're not learning anything. So make sure that you can report clear and concise parameters. You're in any position is understanding rig site and the equipment around you. Knowing where you're at and where you should be or shouldn't be is big on safety. Obviously, if you're walking by a generator producing 120 decibels as you're walking by it, then you should be wearing hearing plugs. Well, not a whole lot of people actually realize that. So knowing just that little thing, those little things help you go a long way in safety, keep you safe as far as slip, trips, falls. Helps you rig up, rig down, You're not going to be in their way. They're not going to be in your way as far as drilling hands and rig crew, casing crews, and all that. Just a few key points on this diagram. Our biggest concern would be the shaker, the shell shakers. Number was at 24, and then the mud pumps. Another one, number 20. Where's that one at? 32. 32. So knowing your type of mud pumps is a big thing for us too. So triplex, duplex, they both have different types of strokes and barrels per stroke, which goes into lag calculation, which I'll get into here in a little bit. So knowing where those pieces of equipment are, what you're actually working with, even though it's not our equipment specifically, it's all stuff that as a mudlogger we really need to know to better perform our analysis and data collection. Big thing that mudloggers get confused with is mud engineers. And yes, from people that don't know what a mud engineer is compared to a mudlogger, we're both mud. We look at rocks, they don't. They don't care about what that rock does. So, in that sense, for us to know what the drilling fluid is doing, it affects our gas readings. If they're running high mud weights, that's obviously going to suppress the gas back into the formation. We're not going to read it because it's not being introduced into the wellbore. Hydrostatic pressure, keeping balance of the wellbore stable, preventing blowouts, major connection gases and stuff where it's underbalancing that pressure and causing a blowout. Sorry. Not a whole lot to say about the mud. It's very important from even our standpoint. While we look at rocks, the mud's what bring the rocks up. If without the mud, we don't see no rocks. Shakers are real important. That's where we collect our samples from 99% of the time. The only other time you won't is if they're fighting lost circulation and we're having to catch it either off the end of the flow line or in the possum belly, and they can't run it over the shakers because they don't want to lose LCM. LCM being lost circulation material. Usually we'll take and put a board or a bucket at the end of the shakers to do a comprehensive sample of the entire interval. So if, say, you're catching 30-foot samples, you don't want to catch a sample in...
Sorry, I came to straighten the projector.
Brought in reinforcements. But rough calculation. It doesn't account for washouts or turbulent flow, which is a little bit more advanced calculations. Somebody a long time ago come up with a bunch of formulas that probably said you'll never need math, and then here you go, now you need math. But that's a common mistake among people that aren't familiar with mudlogging, is the lag calculations it's a real-time representation of the sample coming up the hole, but not where the drill bit is actually at. And the faster you drill, the further out the lag is going to be.
Here, and then after this, I will come back and do some real work on this.
I think you're pretty good. I mean,
Yeah, it's pretty close, but then my OCD's acting up. Whenever there's a break, I'll just text me. I'll come back in and do a real fix of this.
break. We're mudloggers. We don't take breaks.
Well, I appreciate you.
So main factors in lag depth calculations: fluid rates, strokes per barrel, barrels per minute, strokes per minute. Hole geometry, hole size. Your hole size is as big as your bit is. If you got a 6.5 inch hole, that's your entire annulus. So hole volume. Washouts. That's something that's hard to calculate for. Usually it's calculated by watching a sweep. We used to do carbide tests, which is actually, unfortunately, not allowed by OSHA anymore. So that's one way that we used to be able to calculate a lag. We'd drop a carbide down the piece of carbide down the drill pipe, and it would create acetylene that we would read as it come back up the hole, and we could time that drop. Well, now we can use cellophane, rice, little short grain rice. You can use it and see it come back up. Typically, it's just easy to watch a sweep. They know when they pump a sweep, they know when it should come back, and you calculate it from there. And a sweep with the drilling fluid, it's easy to see coming back. On to the most important thing for for a mudlogger is safety. It's underestimated and understated how many dangers there are actually on a drilling rig location. From a metal splinter or wooden splinter all the way to tools falling from the crown, rig hand going up top and working on something and left a wrench up there and it vibrates loose and shakes, drops 150 feet to the floor. I've seen a lot of crazy things happen. I've watched the blocks fall all the way from the crown down, and that's not a pretty sight when it happens. So you got to be very vigilant when you're walking around these locations. Always wearing your PPE. Standard PPE for everybody on location is FRs, hard hats, steel-toed boots, eye protection, safety glasses, hearing protection, and 99% of people on location gloves. Hard to see a company man with gloves on usually. So, understanding these hazards will make sure you have a long life on the rig location. Not every one of them can kill you, but a lot of them can get you kicked off a rig location or not ever want to go back. Metal splinter in your hand goes a long way for not wanting you to go back. H2S, colorless, odorless gas, low concentration, smell like rotten eggs, that it's very deadly. Very common in the Permian Basin, Delaware basins, and a lot of other places. Utica, Marcellus, up in Pennsylvania and Ohio, very common up there. Very common in the Haynesville. Not as common in Oklahoma. Anadarko and Ardmore basins, not very common. I've seen it, but in very low concentrations. Had a rig here, 2 years ago? We were shut down for 3 weeks because H2S, they couldn't get it under control. And off the edge of location. They sent us to hotels. We'd come back out for our shift and sit on the edge of location until they could clear it. So, very dangerous. You always want to wear your H2S monitors. I can't remember the name of the company that makes them. Bellwether? I think Bellwether makes the little yellow ones. They're pretty accurate. Make sure you know where your muster points are. Muster points where everybody's going to meet. You sign it. When you get to location, you sign in. They know you're on location. They know how many people they should have at these muster points. So when they get there, they do a head count. Somebody's missing. They say, okay, well, he didn't tell me he left, so I'm assuming he's on location somewhere, passed out or whatever. And so make sure you know where everything's at. Drilling rig locations as far as muster points, the hazards, the hazards even getting away from the hazard. When you hear an H2S alarm, your immediate instinct is to run. Well, if you run off the side of a rig location or off the side of a rig, it's going to hurt. So making sure you know where you're going in those times is very important. So a lot of companies provide ongoing safety training. We do send everybody to H2S training every 2 years. Your certificate's valid for every 2 years. We do a lot of people through our PEC program that does safe land onshore and offshore. Some of the companies require it. Devon requires safe land. So we send a lot of people through that. Some companies, they have their own training program, so they don't put a whole lot of weight into some of them. Some of them do. It varies. I like them. They're nice to have. IS Net World has a lot of online training courses that people can get for free. So it's one you might look at in the future. just to see some safety training videos and stuff. You can see a lot of different things on there, anywhere from H2S training to, and while you may not get certificates on it because it's not an actual course per se, it's a good heads up. Key components of mudlogging. So for the equipment, we have a multitude of different equipment that we use specifically for us. Gas extraction, we use either an electric or air motor agitator. It's got a motor that spins a shaft, has tines on the bottom of it that agitate the mud and brings the gas, extracts the gas actually out of the mud. Then it's pulled through a polyflow line back to the gas detection system. Total gas sensors, typically there's three that are most commonly used. Catalytic bead hot wire is the older style. It's rarely used nowadays. Everybody's pretty much switched over to infrared. Very accurate for reading methane specifically. While it does read C2, 3, and 4, it's most accurate with methane. Will read CO2 as well. The thermal conductivity is for more higher contents of gases, especially heaviers. So typical swap over from when you're reading gas and you hit, say, 300 or 400 units, depending on where it's been calibrated to, it'll swap over to that thermal conductivity, the TC filament, so it can continue to read higher accurately. The IR only goes so far before it's just not of any use. Chromatograph analysis. Typically, gas chromatograph uses a CC filament for C1 through C5 combustion. And then a lot of people go to the FID nowadays. And that's old school stuff that I think has been around since, the 80s or something like that. It's been going on for a long time. It's gotten a lot smarter. It'll read C1 through C7 on most of them. And so Andrew put this in. I'm not sure what the VOCs are. The photo ionization for VOCs. That one's above me, so that's our geochemist, Andrew. That's a little above my pay grade on brains. H2S detector, LEL combustible gas detectors. LEL combustible gas detectors usually sit in the well, around the wellhead, in the. I'm drawing blanks.
If we want to put Jessica on the spot, she's a geochemist.
Yeah. LEO is around the wellhead in the cellar. In the cellar. To make sure the wellhead's not leaking, stuff like that. More safety measures. Mudlogger can and sometimes is asked to do that. Calibration and quality assurance of those gas detection systems is paramount. You want to bump test with span gases, zero gases. They're usually calibrated 1% equals 100 units. So 10,000 units is a max. That's 100% gas. Zero dilution. Most generally, you'll have dilution of other gases, nitrogen, carbon dioxide, stuff like that. Whereas when we're calibrating them, we're testing with pure gas. So 10,000 units would be your high. We usually calibrate it to 9,900 because you don't really ever want to max out a sensor. So making sure you're bump checking, putting those on the logs. That way your client knows that you're paying attention to your equipment. Just an easy out for them to say, okay, I'm comfortable with it.
Hey Nick, I'm sorry.
Yeah, go ahead.
Back, what's your favorite detector for mid-continent reservoirs, very under pressure? You're way over balance. What's your favorite method of those there?
So in that case,
I'm talking low readings on any gas that you get. A lot of times,
so
reading is more just the actual detection of these low concentration gases in these,
Yeah.
low pressure reservoirs.
In that case, I would prefer an FID because it does read all the way to C7, and so it's more accurate on the heavier side. Even though those gases are gas, they're still liquid, so it'll read those liquids better than an IR system will. I would prefer that.
In Kansas, we've got a lot of drilling for hydrogen.
Huh?
Now, do you use specialized equipment to monitor hydrogen and helium?
Mass spec, yeah. We do have isotope machines, which I'll get into later. That's more of our advanced geochemistry stuff that we use with mudlogging. That does detect that as well in the isomers and everything. So I'll defer that to. But yeah, most generally it'd be mass spec. Yeah. The agitator. It's set up in the possum belly, on the shakers, where the mud comes out of the flow line, goes over the shakers. There's a little pit that accumulates a pot of mud, and our agitator will sit inside that where the mud can flow through and agitate the gas out of the mud. It's then transported via polyflow back to our trailer or mud logging unit. Sometimes, upwards of 500 foot. Pretty much anything over 500 foot, it's going to affect your surface lag calculations. Pumps nowadays are pretty good as far as like speed and volume, so it doesn't affect it. But 600-700 foot, you're starting to see an actual surface lag of the gas coming from the shakers to the actual detection system. We do have IR systems that are remote as well. So those are called pit roosters, the ones that we use at least. I know there's a few others. I think Terra makes a yellow box, I believe, that's actual pit side, so they can set it up pit side and be kind of wireless with it. Pretty handy for the mudlogger not having to run 600, 700 foot of polyflow across the location. It also helps with lag times. Agitators always need to be kept clean. Mud, they do create heat. They are motors. There's friction. So the cooler you can keep them, the longer they last. Maintenance is key with these agitators. You also want to clear out your possum belly. Cuttings are going to build up in that possum belly. It can't flow all the cuttings out all the time. And derrick hands, rig hands, they've got 100 other things going on the rig, so they can't get to it all the time. So you got to check your possum belly. If you got to have a shovel it out. Typically, they've got a hose up there or something. You can wash it out real quick. Takes 2 minutes. But that's just some of the maintenance that you have to do to make sure you're getting the most accurate readings you can.
Hey Nick, on y'all's, talk about PolyLink, is that link factored into lag time, or is y'all's calculations just on pump growth?
So it is when it's necessary. Most generally, our pumps, the pumps that are used in gas detection systems nowadays are pretty strong. So it 30, 45 seconds at most. Anything over 500 foot, you kind of really do start, because you're getting into the minutes at that point. I've seen 1,000 foot of polyflow take 3 or 4 minutes with brand new pumps. So yeah, you would add that into the lag time.
And assuming there's no dilution through cracks or anything like that, obviously.
Yeah, so that's actually a good point. That's where your bump tests and all that come in handy. When you first rig up, good rule of thumb is to always run a gas test, which a quick one for mudlogger's sake is with a Bic lighter. You get that, it's C4 butane, so you get that initial test when everything's brand new. You know what it should read with everything brand new. So if you got any question, you can take that lighter back out there. You read 150 units on that first test. You only read 75 on the next test. 3 or 4 days later, you get 75 on that test, you know you've got a problem. And you'll see that, and you may be in an area where there's no, low gas, you're not reading a whole lot of connection or anything like that. So you have to do those tests to make sure you're running comparatively since day one.
Nick, have these stuffed in the swag bags.
Our Oryx Analytics, it's a sub company of Mid-Continent Welllogging. We build these boxes internally. Our equipment manager builds them. They run a program called Rig Rooster that is also ran on the pit roosters. So we've had a long-standing relationship with the guy that owns pit roosters. Been a really well working relationship. So they're built in Pelican boxes. They're IR systems, IRTC systems. Read C1 through C4. I think the interval's 300, 5 minutes, so 300 seconds. Those have the stronger pumps because they are trailer based. Where the pit roosters, they have a regular diaphragm pump, old style, 2-sided diaphragm pump, and those are typically 50 feet away from the shaker. There's no surface lag even with the older style pumps. So the Fast GC is our version of a FID. We have them built and sent to us. The cool thing on these is the chromat is the full cycle of chromat is 30 seconds. So you're taking a full sweep C1 through C7 every 30 seconds with these. And it's the fastest one I've seen and accurate. As long as you keep it calibrated properly, we calibrate them daily, and as long as you're not in active formation gases, you don't want to sit there and calibrate to 10,000 units when you're trying to read the pay zone of a top company. So the pit rooster, like I said, they're pit mounted within somewhere around 50 feet. Try as close as you can get it, the better. That all depends on power availability. They like to have lots of lights plugged in on the rigs, so there may not always be a plug-in available. So get it as close as you can. It runs a RF signal back to the computer in the mudlogging unit that is good for up to 2 miles. So we really, other than catching samples, we didn't even need to be on location to read gas. Getting into samples and cuttings, this is it's almost becoming a lost art. We're getting a lot of extra data with XRFs, XRDs, and everything, where the actual description of a sample is becoming very hard to come by as far as a good description of a sample cutting. You want to do your visual analysis. You can mostly do that right off the end of the shaker. Get a quick clean of the samples. You can tell, sand feels like sand, limestone feels like, shale feels like shale. It's soft, will crumble in your hand, create, clay. It's clay rich, so it'll gum up on your hands. And then the rest is, typically limestone. So that first visual analysis, confirms, and then you do a more in-depth analysis back in the unit. That's where you get into your microscopic analysis with your alizarin red, your HCl. Alizarin red stain is a stain that helps differentiate between limestone and dolomite. Dolomite will not, typically will not stain right away. Everything stains with alizarin red, just so you know, if you leave it in there long enough. So limestone will stain red almost immediately, or bright red almost immediately. You can put some alizarin red on there and then splash some few drops of HCl on it, and it'll dilute it to where it'll actually react with the limestone better, the calcite in the limestone. Sand, you're looking at, your sand grains, your sizes, and I'll get into all the descriptions and abbreviations for all those here shortly. Cutting analysis, it's going to help your client, assess the formation, quality of the reservoir, properties. If they're drilling a sand formation and all of a sudden you see 500 foot of shale, quality of that reservoir has kind of dropped off, hasn't it?
Hey, Dave,
Yeah.
would you mind talking about, you wanna call it logistics of you're sitting in the trailer and you're gonna go get a sample, clean it? Like, what is the time frame? What do you do from leaving the trailer, going to taking the sample, cleaning it, drying it? How long does that take?
Okay. That's a good question. So it can take as fast as you can, as long as you want, or as fast as you want. A lot of times we are put off in left field, 2,000 feet away from the shakers. So, and I've never seen any mudlogger run across location to get a sample. I've never seen any safety man allow a mudlogger to run across location to get a sample. So it really just depends on where you're at as far as on location in relation to the shakers. Typically, you're gonna, okay, sample time. You put your hard hat on, boots on if you take them off when you go inside. Go out, get your sieves, you're ready to go. Your sieves is just what you're catching your sample in. Walk across location, 2-3 minutes there. Typically up the stairs, get to where your bucket or your board's at. Scoop your sample off, wash it. A lot of people do it differently. If they don't have a hose at the end of the shakers, like most rigs will do, because they use the hose to wash off the shakers screens, make sure there's no holes in them and stuff. If there's a hose there, a minute or less to wash a sample. You can sit there and spray the hose in there with light pressure while it's vibrating on the shaker, and it'll vibrate the mud, oil base or not. It vibrates it off real quick. So, and that helps in drying it as well. So you're at 4 or 5 minutes there, and then 2 or 3 minutes back to the trailer. Do a little bit more of a wash there if you need to. If it's oil based, you might even, this is where it gets kind of diluted in time, because some clients require certain washing and steps. A lot of them want mineral spirits or acetone. They don't care about cut or leach or anything like that. They just want them clean, dried, and then taken. So I would say with any given time, 7-8 minutes, about a max is what it should take. So, and then that could vary if you're catching ISO jars or double samples, or I've caught 4 samples on every single sample one time. So I don't want to go back to doing that again. But
Then there's wet samples.
there's wet samples, there's dry samples, samples in quart baggies. I mean, there's a lot of variation, but a normal regular sample, 7 to 8 minutes. Building a mudlog, data acquisition, this is where everything's going to go. Like I said earlier, the mudlog is a one-stop shop for any and all information that is on that drilling location. The only thing you're not putting there is, pipe showing up. Everything that has to do with drilling parameters, all that's going on the mudlog. It's continuous, real time, up to date as best you can for every single report. The most accurate it can be from the time you send it off to the time the client reads it. And you may have 2 reports a day, you may have 10 reports a day. You may do,
Talk a little bit more about the microscope analysis. Is that something you guys do in-house?
Yeah. Yeah, so the microscopic analysis, you're looking at the finer details. So like in limestone, you're looking at the crystalline structure, the texture, color. Colors kind of it varies, obviously. Limestone can be a lot of different colors. Texture be a lot of different textures. So that's where the microscope analysis comes in. You're getting a finer detail of that, building the sample description off of it.
Is that something you do back in the lab, or do you do it off-site?
Yeah, we do it on site. Yeah, everything a mudlogger does is on site. Um, Now there's extra stuff that can go back to the lab, like XRF, XRD. Um, Most of that stuff's done back in the lab. We do also do on site XRD and XRF. Um, we've done XRD on site I think 3 times now, and XRF we do on site all the time. Not just depending on if the client wants XRF. Typically, that's done on site. There are some that'll send us samples that wants XRF ran on it after the fact. So it's one of them things that time doesn't affect the results of XRF or XRD. So
What are typical terminologies you use in describing your, for instance, your
so yeah, I actually have slides on all that. I got a bunch of slides on descriptions. So descriptions are done with abbreviations, for sizing. So a lot of geologists mostly can work it out. A lot of people that aren't in geology looking at rocks all the time are like, what's waxstone? What's mudstone? And then to put that as a abbreviation, they have no clue. So yeah, I have a bunch of slides on that coming up.
I got a dumb question. What's the difference between XRD and XRF?
So XRD is X-ray diffraction, and XRF's X-ray fluorescence. I think I actually have a slide on that too. X-ray diffraction, I believe, is mineralogy. Am I right on that?
Yeah, it measures the space between the angles, and we can tell the mineralogy.
Yeah. Helps you analyze the trends going forward. It helps the client analyze what they're looking at as far as like their reservoirs and stuff. That trend data helps a lot, especially in horizontals, because you can see, okay, we're going up here, and then this thins out, at this depth, so we need to go back down. Well, it thins out down here, so they get that trend of where they need to go. Speaking of mudlog, put everything going on the mudlog. The drilling parameters, ROP, rate of penetration. That's one of the biggest factors of your gas content that's being introduced into the wellbore. It is the biggest factor. Faster you go, the more gas that's liberated and put into the wellbore. Being able to tell whether your gases are from an ROP increase or a true formation gas is a fine line between knowing where you're at as far as the formation and what type of formation you're drilling, limestone, shale, sand, and knowing what it should be doing. ROP will affect the cutting size as well. The faster you're going, the bigger cuttings you're getting, because it's taking bigger chunks. Now, in that same token, the deeper you are, the finer the cuttings are, because it's getting beat up all the way up hole by pipe spinning in the hole. So you may come out with powder at 20,000 feet. If it's drilling 400 foot an hour and they're got 20,000 foot of pipe, that could be powder. That's probably going to be powder coming up mostly. Even with PDC bits, it used to be a lot better when it was tricones way back when. Get really clean samples with tricones. Mud flow. Keeping an eye on your mud flow helps to ensure you're getting your gas detection, your gas agitator in the mud consistently while you're drilling. If you see a dip in the flow percentage, that's going to bring that level down in the possibility where your agitator is sitting. So it's going to affect your reading as well. The higher you get a higher percentage, say you end up taking a kick of gas into the wellbore, it's going to bring volume up with it. So it's going to bring that percentage of mud flow up and drown your agitator. Drowning your agitator will either cause you to suck mud into your polyflow line, blocking all gas readings, or it can take and it'll just drown it enough to where it can't break out the gas out of the mud. Um, typically, gas is, depending on the drilling fluid, OBM, oil-based mud, gas is lower, about 3 inches from the top of the mud, pretty much at all times going into the possum belly. In water-based mud, it's a lot higher, thinner mud. Typically, the viscosity is way thinner, so it's able to escape it on its own. So you need your agitator up higher in the mud to where if you do get a drop, like a small loss of circulation, and that fluid drops in the possum belly, you're going to lose all your gas for that little bit of time, and it may be permanent, it may not. You just have to adjust your agitator to compensate for that. That goes along with pressure tracking, the kicks. Typically, we're the first ones to see it because we're paying attention to the screen most of the time. We have nothing better to do, look at samples and look at screens. So and we're not MWD, so we're not movie watching. Paying attention to those help you safety-wise for the entire rig. If you see a pressure spike, obviously you're going to sit, if you see something, say something. Not all the time is it the formation's fault. Mud motors go bad. I mean, it's a mechanical piece of equipment that directional drillers use to steer the well, and they do go bad. Anything mechanical can and will break. So when they go bad, usually you'll get a pressure spike. Has nothing to do with formation, but it's still something you need to confirm and look at from a safety standpoint alone. Let alone talking with your geology and department, drilling engineers, and all that. So another thing to put on the mud log. So excuse me. On the gas detection and analysis, so that's our major part of the analysis is the hydrocarbon analysis. Identifying the productive zones, especially in a vertical wellbore. There's multiple zones those guys are shooting for throughout a vertical that it's maybe 10 foot thick, it may be 100 foot thick, it may be 1 foot thick. And, to be able to analyze that specific foot from a mudlogger standpoint helps the client tremendously by saying, okay, this is here, I need to look at this more, which in turn they can use a wireline log, seismic, and all that to actually look at it more in depth. But it starts with us as mudloggers on that hydrocarbon analysis. And again, safety hazards, taking spikes, gas kicks, making sure you're paying attention to what your gas is doing, high flow, low flow. You've got a trend of what should be reading. So you're kind of in tune with your equipment to be able to call out those safety hazards.
Can you elaborate more on how do you detect gas shows, like few indicators of those?
The indicators of
Gas shows.
so the gas is being liberated as it's being drilled, and we have an agitator in the possum belly that's breaking the gas out of the drilling fluid. Well, when it comes back to our equipment, when you're doing active drilling operations, and it's a constant stream of gas that's coming back to our gas detection equipment, and it's background. So you'll have a trend of just average background gas, and then a spike where you hit a formation that's actually producing will spike an influx of gas and oil into the wellbore. That'll come up all at once. So when it hits the agitator, it's getting pulled back to the detection equipment all at once. So the concentration. So that's technically what we're reading is concentrations, not an actual unit. There is no conversion for units to PSI, units to MCF, or anything like that. Everybody reads in units, but there's no actual conversion for it. So, no, but yeah, it's just a sudden influx of gas into the wellbore. That's what we're taking as connection gases, formation gases, downtimes. Connection gases are when the pumps are shut off, the fluid's static. So the fluid just sitting there allows for the formation. If the pressure is higher than the hydrostatic pressure on that particular formation, it's going to allow an influx of gas and oil into the wellbore. The hydrostatic pressure while you're flowing is more constant, and it's moving the gas as it's coming in. So you're not getting a big spike, you just got that average trend. When the pumps are shut off during connection, it's allowing it to suck into the wellbore, causing a bubble that comes all up at once. And that's where we get our connection gases. That answer? Okay. Hairline fractures, vulgular, pinpoint vulgular. I think there's a couple more in there that I don't even know. Then we got scattered bright yellow fluorescence. Then immediate milky blue cut. So that's like a flash cut. Flash cut's instantaneous. It just explodes when your leach fluid, which is typically lighter fluid or acetone. It depends on where you're at, depending on what type of fluid you use. Oil-based mud will cut with acetone every single time. It's hard to use acetone in a oil-based mud system because it will cut everything. So I like to use lighter fluid in that type of situation because it's a lighter, it's not as harsh as an agent. So you can actually clean the rock and get the actual leach out of the rock instead of just the surface. Then you got thin blue-white residual ring. That's the ring after the lighter fluid or acetone dries. That's what's left over of the oil that has just dried with the lighter fluid on the side. And this is all done in a UV box. So UV box, I can't remember the wavelength, I think 3600, something like that. But UV box is just a little box, got a UV light in it, black light, that will fluoresce hydrocarbons and oil and hydrocarbons, mineral fluorescence also, but mineral fluorescence is a lot lighter, typically dull yellow, whereas hydrocarbons are a bright yellow-green type fluorescence. You can sometimes associate gases or heavier gases and liquids to the color of cut sometimes, depending on where you're at and how often you're doing it. You can kind of get a trend on what you're seeing. So as if you're seeing blue to, milky white cuts over 1,000 foot, and all of a sudden it turns kind of green, something's changed. So it's kind of an indicator that you can keep in your mind as you're drilling. So limestone, you're dealing with colors, lithotype, crystal size, textures. Same picture, whole bunch of different colors.
Hey Nick, can we take a break real quick?
Sure. Going into the type, mudstone, waxstone. These are a lot of ones that aren't typically used on a mudlog, but are questioned if need be by a geologist. The mudstones and waxstones are going to be where it's softer, so it's typically it's balling. It'll ball on the bit and create drilling problems. So that type of stuff is helpful to know as far as just being able to, for efficiency purposes. So crystalline is a big one because that goes back to your hardness. The finest being cryptocrystalline. It's too small to see even with a microscope. The crystals of the crystalline structure of the limestone is just so tight that you can't see any gap between it at all. Micro, very small, hard to see in a microscope, but can be seen. Very fine, size of sand grains, basically, where it's the crystalline structure. You're starting to see slight gaps. So it's just limestone's basically put together, interlocking crystals with the structure. It goes all the way to very coarse. Basically looks like big chunks of sand grains within the limestone. Even though we're talking about sand grains in limestone, it's actual limestone. Textures, smooth, dense. These are all how it feels. So talking about like massive. Often accompanied with shale, argillaceous clay type material. Sucrosic is more like powdered sugar, so it's sugary feeling. Chalky is just like it sounds, like writing on a chalkboard. And a formation called the Austin chalk, you can actually write on cement with it like you can like sidewalk chalk. Detrital, coming out with pellets, fossils, fossil fragments, oolites. You'll see a lot of that within the detrital limestones. Lithographic, more porcelain-like texture, always with cryptocrystalline, very hard also. Going into sandstone. So this is a picture of the bromides, and it basically looks like little glass grains. Perfectly, clear, crystal clear. Most generally, your general sands. This is pretty much bromide to a T. Most generally, sands are anywhere from clear to opaque. You can see through them. Some you can, some you can't. Some look like limestone, but it feels like sand. Going through the description, you got predominantly unconsolidated clear quartz grains. Quartz being a major, one of the major components in it because silica. Round to sub-round, that's a shape. Then some subangular, also shape. Subangular matters because it's more coarse, so it's going to tear. You'll feel it. It's going to also be more wear and tear on the bit and drill pipe and all that coming up the hole. You can actually hear it in your screen when you shake your screen. You clean your sample and you're sitting there cleaning it. You can hear it in your screens. Well consolidated. Consolidation is just how well it's put together, how well the rock as a whole is put together. You're seeing, well, some of these are individual sand grains. They're actual clusters for the most part. That's your consolidation. You got well consolidated, moderately well consolidated, poorly consolidated, where you're seeing almost all individual sand grains, or unconsolidated. Cementation, the bromide here is siliceous cement, so it's all silica-based cement, whereas most of your like Tonkawas, Red Forks, they're going to be more calcareous cementation, or dolomitic cementation even. So you got that calcite factor, magnesium calcite, in the holding the sand together. Sorting, this is moderately to moderately sorted. Sorted is grain sizing. So if it all looks the same, you're going to get moderate to well sorted. If you start seeing fine grains to very coarse grains, you're going to get, if you got a lot of intermixed grain sizing, poorly sorted. And we go into porosity, slight to moderate intergranular porosity. So you're actually looking at the porosity within the grains itself, whereas limestone will fluoresce the entire rock, sand will fluoresce an individual grain, and that's it. Or it'll, not just that grain, but you can see it where it's just an individual grain instead of the entire cluster of grains. This had bright yellow to blue fluorescence with a bright milky blue-white flash cut. That's another one of them immediate cuts Whereas, you hit it with your, leach fluid, and you're immediately seeing the hydrocarbons leach out of the rock formation. Faint blue, yellow res ring, and then very poor flotation to the mudlog in some way, shape, or form, whether it be an actual curve, like you can see here with the ROP in the blue line, the red line being the gamma ray. Over to the right, you got your gases. The dark blue line on the right is the total gas, where the other ones are C1 through C4. So in some way, shape, or form, every single piece of data that's being produced while drilling a well is going to be on the mudlog somewhere. The more, the better. It's the one-stop shop, like I said, for any and all data that could ever be needed for a mudlog. From the time you get there to the time, we may not even be there during spud, but we're going to have that spud date on the mudlog. So we may get released before TD of the well or before casing's done. But that date's going to be on there. We'll call and get the date afterwards. So being able to see and gather all that data and put it all on a mudlog is paramount to what we do as mudloggers. Providing a real-time picture of the wellbore as it's being drilled with everybody else's input, that we don't actually interact with the people as much as we do the wellbore itself, because we see all this data without actually talking to somebody else, because it's all produced, but we're the only ones that put it in the one spot all together. That goes along with like picking the difference between the connection gases, formation, and downtime gases, interpreting those and calling them correctly. It's easy to sit there and say, well, this spike is a formation gas. Well, we had a connection at that point, so that's a connection gas, and vice versa. It's easy to call formation gas a connection gas, or connection gas a formation gas if you're not paying attention. That goes along with more of the data that you can get pipe tally, calling Kelly Downs. Turning all that into data in a clear and concise manner and putting in a visual representation and then reporting that and communicating everything that you've collected during your shift and then some to your client. One of the most important things that you can do is communication. If they don't know what you're gathering, what's the point of gathering it? Making sure it's timely. It goes along with the safety issues there. If you see a spike and you say, well, I saw a spike 6 hours ago, what good is that going to do anybody? So being timely with your reporting, communications of all levels, whether it be a safety issue or reporting your daily reports or LASs, anything like that, got to be on time and effectively communicated. Applications for mudlogging, there's quite a few. Goes along with real-time decision making. It's one of them overlooked until it's needed type situations. It's very important to have all the data, and because when it is needed, it's there, and it's probably the most important piece of equipment that a geologist can have of their well. It enhances drilling safety. Like I said, we're the ones paying attention to most of the equipment all the time, 24 hours a day, whether, two-man shift, one-man shift, you're always paying attention. You've got alarms set for certain things. It's pretty easy for somebody to sit there and ask, well, what was we doing here when that spike happened? Mudlogger can usually tell you. Saying, smartest person on location is usually a mudlogger, but he's never asked anything. Optimized drilling operations. Like I said, efficiency helps with efficiency. ROP, everything's faster. The faster, everybody wants to go fast. So, the efficiency in a mudlogging operation from collecting 6-minute samples over 10-minute samples, or 10-foot samples to 30-foot samples. Providing that efficiency for a client, it helps tremendously to improve their drilling operations and processes. And if you would like more information, ta-da! I think that was the last one. Yep. So there you go. I was only 56 minutes early.
Next speaker's here, so we're gonna break too, but any questions or?
Yeah, anybody got any questions or?